Hello and welcome to Environmental Science here at NICC. This starts our unit on energy, and so the readings in the textbook for these chapters, for this unit rather, are going to be chapter 12 and 13 in the book. Chapter 12 is looking at geology and non-renewable mineral resources, and then chapter 13 is looking at energy resources, and these two things are linked. When we're talking about mineral and non-renewable resources, we're definitely including things like coal in these conversations. And so understanding where these resources come from, how they're built and developed within the geological structures that they're found in, and then how do people extract and utilize these resources, not only from an energy standpoint, but also from a metallic and other sort of human use standpoint, is an important part of the equation that I hope you get from this course. First part of chapter 12 starts going through the rock cycle. And so geological formations do move in these cyclical fashions that we see similar to the water cycle and cycling with air and things like that, except the time frame that they undergo is much slower. The depletion of these geological resources occurs in a human scale and over much faster times than these geological processes that would then regenerate these resources. So when we're talking about these geological resources, although technically they can regenerate over millennia or eons, in any practical human sense, they are non-renewable resources. We get sort of one crack at them to use them, and then they're gone in any meaningful human sense. When we get into section 12.3, we really start talking about some of the environmental impacts of exploitation of these non-renewable resources. And the reality is that modern society is built on the exploitation of non-renewable resources. Without coal, without iron mining, without the advances in technology made possible by these types of technologies, modern society would not exist. And so that's an important consideration when we're talking about and having this discussion, is that the foundation for the sort of modern human lifestyle is based on the exploitation of these non-renewable resources. I think challenges moving into the future then are, how do we maintain our sort of current standard of living, which everybody expects that when we turn the light switch on, the lights come on. Everybody, at least in this country, expects that that's going to happen. And if that changes, that represents a fundamental change in how our society is structured. So I think moving forward, how do we keep and maintain our standard of living, but moving towards sustainable models is an important question, and hopefully one that we consider throughout this course. So when we move past sort of the impacts of utilization of these non-renewable resources, which are many and very extreme in some cases, again, that, if you recall from my introduction, that's a lot of my background and training comes from looking at the impacts of utilization of these non-renewable resources. But moving past that, the rest, or the next section of the chapter rather, talks about sort of how the geology on this planet functions. So looking at plate tectonics, looking at the movement of magma and these rocky structures throughout the surface and subsurface of the Earth. Looking at earthquakes, so how is it and why does the Earth move in the way that it does, the development of tidal waves and tsunamis and things like that. And again, it's linking these natural disasters or natural events. I mean, the Earth has always had earthquakes, and there have always been tsunamis and things like that, but they only become disasters where they intersect with human development, at least in a human sense. Hurricane Katrina and the massive tsunami that sort of wiped out much of New Orleans was a human disaster. It wasn't a natural disaster. The natural ecosystem in the delta of the Mississippi River has a long history of absorbing these storm surge floods and then releasing them back into the environment. There's, of course, destruction associated with a major storm and things like that, but ecosystems are resilient and they will bounce back. Where humans run into problems where we build in places that are subject to these natural events, and then how do we respond to them really becomes the question when we're talking about natural disaster. And I think that's an important concept. And building resilient systems means looking critically at where, how, and why we live the way we do, and then what sorts of changes can and should we make in our environments? Should we be building in a place like New Orleans? Should we be building in a place like Miami? Should we be building in Virginia Beach? Should we be building in Houston? These are areas that are subject to these sometimes very major events. For that matter, should we be building in downtown Cedar Rapids? In 2008, extensive flooding from the Cedar River in Cedar Rapids wiped out huge amounts of property, and the city condemned some of that property and has moved it back into a more natural state to say this is not a fight that we think is worth fighting now and into the future. So these are interesting questions where we have these intersections of the natural world and the human world, which the reality is they're always intersected, and we are, as humans, that we are part of the natural world, but very often we sort of view ourselves as separate and distant from nature, but we are definitely part of nature, and our interactions with the natural world are important in consideration for where and how we live. As we move into chapter 13 from chapter 12, we really start talking about energy, and specifically where do we get our energy from and what does that actually mean, and there's some pretty good breakdown of what that means and where we use our energy, and really those sources of those energy sources rather. And when we're talking about sustainability as a concept, when we're talking about where do we get our energy from, those sorts of questions become really important when we're saying, is this a fossil resource? Is this a renewable resource? What goes into building these sorts of energy resources? I start out looking at sort of traditional fossil resources, oil, coal, things like that. It's a good thing to know where these resources come from, because knowing and understanding where these resources comes from helps us as members of a society be better, or at least more educated consumers, and we can move our values and in the end dollars into resources that we're interested in. By the time we get into 13.3, we're talking about nuclear energy, and nuclear energy is a major player in the production of large energy systems for, say, the power generation grid in the United States, and many countries are highly reliant on nuclear energy. The United States is less reliant on nuclear energy than many others. Environmental disasters such as 3 Mile Island in New York and Chernobyl in Ukraine really drove public opinion away from nuclear energy. But if we're looking at a purely carbon sort of content argument, nuclear energy is lower on the carbon content, but it is a non-renewable energy resource in that we mine uranium and we sort of have what we have. It's not something that we can come back to in the same way that we can come back to solar or wind in essentially an infinite way. The book then moves into talking about energy efficiency, so how we use our energy, switching and moving towards sustainable sources, really improvement of the grid and things like that really are part of the important conversation when we're talking about, again, moving towards sustainability. Energy use in homes, in different places. Then we're talking about renewable sources, biomass, hydropower, biofuels, and then transitioning from fossil sources into sustainable, renewable energy resources. I think the projections in figure 13.5 do a good job of sort of showing where these different energy levels are, and I think it gives a good idea for you as students to say, well, I didn't understand that oil was such a major component of energy resources, but we really use a lot of oil day to day. We aren't using it to generally generate electricity, at least not in this country, but we use huge amounts for transportation. So these sorts of issues are addressed in this chapter, and I think the chapter does a pretty good job of breaking down these different energy resources that we have and how we use them and sort of what alternatives there are and some of the costs and trade-offs that come with all of these. So for the energy unit, that's chapter 12 and 13 in the textbook, and I'll talk at you later.